For each graph below, find the slope of the given line. We're going to leave this piece for now about using a slope formula, and we're going to look at A and B first. So the main thing that you want to know is that you're hitting an exact point. That's an exact point on the graph. The origin is an exact point on this graph. This is an exact point on the graph. Anything in between is not exactly hitting at an exact point. We saw from class discussion 1 that between any 2 points, a line's going to have the same slope. So we can really just count the rise, how many boxes we went up, over the run. Right? We went 3 boxes up, 1, 2, 3, and 2 boxes over. So our slope in this case is 3 up, 2 over, and we're done. Okay, let's do that again for the next one. This is an exact point, so is this, and so is that one. That's all I see on this graph. So from left to right, I see how much I am rising and how much is my run across. 1 box up, 2 boxes over. Okay, so when we look at parts C and D, we can't use this method anymore of counting boxes, and that's when we're going to need the slope formula. Now, since we can't count boxes and we can't find our rise, we're going to be looking at the y values instead, the 7 and the 3. And since we can't find our run, how far we're moving on the x-axis, we're going to look at the 5 and the 0. So this is what I meant when I said any 2 given points are x1, y1 and x2, y2. So we're going to call the first points x1, y1, and we're going to call the second point x2, y2. So now, when we want to follow the slope formula, y2 minus y1 is just 7 minus 3. x2 minus x1 is 5 minus 0. 7 minus 3 is 4, 5 minus 0 is 5, and we got our slope of 4 over 5. Okay, so if we do that again, in part D, we'll call our first set of points x1, y1, our second set x2, y2. Okay, then we follow our slope formula. On top, we're doing y2 minus y1, or 3 minus 0. On the bottom, x2 minus x1, or 9 minus 5. Simple subtraction gives us 3 over 4 using our slope formula.